Hi, by the way. Are you guys here for the next meeting? We're trying to get everyone out.
Testing.
I suspect she preferred to use the live.
Is our audio guy here?
What?
Our AV guy?
No, I think they're calling. Why?
So I'm not getting any connection.
Oh.
Is that him over there?
I suspect there's one at the table, and I suspect there's a switch somewhere. So Gary, can you use this one?
No, I can't. Well, over. I need to make this one work.
Condolations? No, that's condolations. Congratulations to you.
Thank you. I think it actually is. We'll see.
Yep.
I might come crying back. Hey, Leslie. Rock and rolling. That one was on the table. It was live.
Yeah, we should use.
Well, we put it this way.
Yeah, we only need one.
You stand up there.
But I need that one to reach here, then it won't. So I need a longer cable, or I need that to be in there. Can I steal this one for a moment and just bring that back?
When you do
Oh.
the panel part or talk about it, you can be up there. I can get angle. I can see these
The one on
chairs.
your feet.
Whoever's
Try that one, Steve. Try that one.
Maybe a good.
Try this one?
Yeah.
And can I step out at all? Or
Oh, yeah, you're fine.
You're rocking, James.
You're fine. You can come out anywhere.
I'll switch it
just
back one more time.
That particular chair.
I have no idea where that is.
I didn't want to sit, I didn't want to sit in the middle where I'm
I know it's working.
So over there, I've got a nice,
So there you go.
I've got a nice shot of this, but I don't have that. Hey, Andrew.
How are you? Do you want
Good,
to
we
have
have
this
to
now?
all this way to each
or-
other.
Okay.
I know, I have to come over to you sometime. Chris Griffiths keeps telling me.
You're gonna run out of time. I'm gonna move back.
Oh, where are you moving?
I'm moving back to.
Well, that's not exactly what I'm looking for.
Yeah.
Oh, when are you doing that?
As soon as I can afford a house.
Oh.
I missed a house a couple of weeks ago.
Almost there.
Listed at 629.
That means the
I get
lav is working for us?
I haven't tested the lav yet.
Oh, wow.
Yeah, it's.
I don't at this moment. Can we talk? Can we talk after? Yeah, for sure. Okay.
Testing.
Yes, because exactly.
Okay.
Also, it's a weak mayor system, so he doesn't actually have any power.
He provides comedy for the rest of the world.
Yeah, exactly.
Works on my computer.
So you're all fine with, I will drive the slides, and you can speak from here?
Check, check, 1, 2, 1, 2.
They noted, is the end-to-end principle, as articulated in the papers by Salter, Reed, and Clark, originally articulated as a question where best not put functions in a communication system. And that's a paper that dates back to the mid-80s or 90s, I'm not remembering at the moment. In ensuing years, the RFC goes on to note, the principle has evolved to address concerns of maintaining openness, increasing reliability, robustness, and preserving the properties of user choice and ease of new service development. And these were not necessarily originally part of the original articulation of the end-to-end principle, but they are things that we have come to appreciate as being important about the internet as distinguishing features from other networks. So in terms of our current realities, fast forward a decade, we certainly still want to build an internet that features that sense of increasing reliability and robustness. of preserving the properties of user choice and ease of new service development. But we have significant challenges to achieve that. One of which is just the natural progression of business evolution and natural trends in the whole universe of internet using people and organizations. Another which is reactions to the revelations of pervasive monitoring as we've experienced them in the last year. Any number of reactions, and I really am trying to be careful in saying that it's not just acting in response to, but excessive reaction to the revelations may or may not take us in directions that are less than optimal. And two possible considerations there are a drive for localization of data and services that are meant to be global, and or sort of just madly driving towards encrypting everything everywhere all the time because more encryption is always better. So where we're going to go with this topic today, or at least where I hope to go with this topic today, is to have a look at does the end-to-end principle matter in today's internet and going forward? And if the answer to that question is yes, and I of course heartily hope it is, how does it matter? So we'll be looking at that from any number of different angles. So as I said, we have a fine panel here. We have Fred Baker, who will take us through considerations of the network perspective. Andrew Sullivan is going to look at the infrastructure point of view, and Harold Alverstrand will take up the endpoint. And with that, I would invite Fred to provide his comments.
So, thanks, Leslie. Now, she asked me to talk about the smart network, and that really conveyed in 7.4. And now, if you read the two statements, you'll realize that the second is a special case of the first. The paper, as it goes through and talks about them, actually applies both sets of logic. But to give you an idea of the difference, when the application decides to talk to the network underneath it, which starts from its perspective from the socket API, whatever it is that's underneath it gives the network an address and says, please send this parcel of information over there. And it doesn't tell the network how to get it there. The network is presumed to have the intelligence to already know. So the network has to have, in order to accomplish the goal that we give it in the internet, has to have a certain amount of intelligence. So now, what is the end-to-end principle as I read Salsa? It's that whatever layer you're in, the layer below should do what I expect it to do. If I handed the packet and wanted to go somewhere, I would expect that packet, not some different packet, to go there and not somewhere else. Okay? So a lower layer should do what the upper layer expects. And that applies recursively. So the paper talks about, for example, the differentiation between application layer retransmission and retransmission at a link layer. And in 1984, what he was talking about was LATP. In 2014, we'd be talking about Wi-Fi. Okay? But may I note, TCP is not in the application. TCP is in the transport. So now we're comparing the function not of the application to the link layer, but of the transport to the link layer. So the principle applies recursively as you go down through the layers. A lower layer should do what the upper layer, whatever it is, expects it to do. And when it talks about lower layer performance improvements, it doesn't say thou shalt not do that. In fact, it explicitly doesn't say thou shalt not do that. What it does say is if you're going to do it, there should be a good reason to do it. And why do we do Wi-Fi retransmission? Because it helps. Okay? So what there should be, as I understand the end-to-end principle, is if you're going to do something that would appear to violate it, there should be a really good reason. You should be able to measure the difference. Now, let me back up. You notice this title. In 1997, I believe, Eisenberg and Reed put out a kind of a manifesto, a restatement of the end-to-end principle, in which they talked about the stupid network. The comparison point there is to the telephone system of the era, which was being pushed as the intelligent network. And what they were saying was, maybe that's not the world's greatest model. We want the network to be done. And in many respects, I would agree with them, but considering that the network has to have certain kinds of intelligence, I don't think it's fair to call it stupid. At the same time, I don't want it being smart. I really don't want it being smart. Okay, the statement of the principle, as I would understand it, is that the network should be predictable. It should do what I expect it to do. So, okay, what does the predictable network do? Well, obviously, if I hand it a packet, it takes it to where I wanted it to go, and it delivers it. It also routes traffic in a manner that enhances the operator's ability to deliver that service. It doesn't just pick a willy-nilly route through the network because it happens to have the lowest metric, which is what OSPF or ISIS or maybe RIP would do. It might very well say, I'm going to pick a route based on the availability of bandwidth and therefore the costs that a service provider incurs as traffic crosses the network. So it might route things in such a way that the company stays in business. That's a good thing, right? And it operates transparently. I can observe how the network works. I can see that it crosses a certain path. If there's a problem, I can find the point at which the problem occurs so that I can go call the right guy and say, please fix. There are some things that the predictable network, I would submit, does not do, and that is behave unpredictably or behave contrary to the prediction. Part of that might be behaving intermittently. Sometimes I can get a packet through, sometimes I can't. Anything that forces us to go diagnose the behavior of the internet, figure things out, call somebody, sort things out, that's the exception. That's the case that we don't want to have happen. Why do we not want to have happen? Well, if I'm an operator and I'm trying to run a network, it costs me money. If I'm a user and I'm trying to get a file from here to there, I'm unable to do that which I set out to do. Okay? So the network should accomplish that for which it was purchased, that for which it's intended to be there. Now, Leslie asked us to give predictions. In 2020, which is just 6 years from now, it seems like so far from now, but it's just 6 years. What would we expect to see changing in the internet as kind of things evolve? One of the big concerns in the network today is that a large amount of the global internet is actually hidden behind carriers that see their network as a proprietary service. And specifically, I'm thinking about the mobile internet. To the extent that that doesn't interoperate well with the rest of the internet, doesn't allow services that are available across the internet to be accessible to its customers, I'll argue that it fails its customers. It doesn't accomplish that for which it's set out to do. We have a lot of complexity in the internet today. The question came out on a policy list 2 days ago, whether putting voice on IP as opposed to in circuit switch or whatever networks would make it more easy to track behavior in traffic. And well, actually, it's really easy in the telephone network to track things. In the IP network, I have to not only wonder whether it's in IP, but if it's tunneled over another IP, whether it's encrypted in IPsec, whether it's rammed into MPLS, thrown across 2 cans and a piece of string, I have to think about the structure of the network at the point at which I'm looking at it. Okay, so there's a fair amount of complexity out there, and I'm starting to see operators saying, I want to simplify the network. I want to reduce my costs. I want to improve the security. I want to perhaps go IPv6 only, not do IPv4. with the direction of simplifying the network and reducing my total outlay, I would expect to see more of that as time progresses. But so two sides, kind of concerns with walled gardens and the direction of simplifying the network.
Thank you. Don't run away just yet. Just maybe we can have a couple of questions, just to make sure that we're all clear on your position and predictions. So part of what I hear you saying is that it's not even necessarily a question of how smart or dumb the network is, so much as encapsulating that intelligence in the network for network purposes.
Right. I believe there has to be intelligence in the network for it to operate in the way that we frankly expect it to be and have expected it to be since 1968.
Right.
That said, that intelligence should serve exactly that purpose.
Right. Okay. And Andrew or Harold, do you have any comments or questions for clarifying Fred's position? No? You're being shy still? Okay.
Okay.
Thank you, Fred. And Harold. Oh, no. Sorry. Right. We'll go to the middle before we go to the endpoints. Andrew.
Thanks. So one of the difficulties that I had when I started to look at this is whether this isn't just the network, because of course once you start to talk about infrastructure, naturally people start to think about switches and things like that. But in the business that I'm in, I like to think about the difference between the bits flowing on the wire and basic routing and that sort of stuff, and then everything else. So all the servers, all of the nasty things that we do in the middle. And I happen to work for a company that does some of these sorts of things. And it seems to me that this kind of infrastructure specialization is something that we're gonna have maybe increasingly over time. And part of the reason for that is obviously capital expenditure and that sort of thing. It's really convenient also when you're trying to do something and you just spin something up at Amazon or whatever, and that's sort of handy. But the other thing that happens is companies have gradually adapted this model of sticking to their core business. So they don't want to be in the business of running their DNS or mail servers or something like that, because it's a distraction and you've got to keep people on staff. So the thing is that this turns out to be a compromise when you're one of these. I like Tom Waits, and I think this is one of the best things he ever said. So when you have these kinds of infrastructure operators, there are things that we're all going to do. We rely on this predictable network. We have to have a network that is very much like Fred was just describing, and that's super important. But we also have to alter the behavior depending on the user, because our customers are only going to buy stuff from us if it's roughly as good as what it would be if they were running it themselves. And naturally, we can't, we don't want to put something in everybody's point of presence, because the whole point of this is that we're going to make money off the difference in the economy of scale. So you end up having to alter the behavior of what you're going to do depending on properties of the customer's network or their customers or whatever, and the users that are hanging off that network. And the difficulty is that there are a lot of us, and we're all doing it at once, and that's really where I think some of the compromises come from. So I'm going to be really brief here. I think that in 2020 we've got certain tendencies that are good and certain that are bad. And I think the good thing is that if we get technologies that tend to give these infrastructure points enough information to make an intelligent decision. So think about something that says, oh well, this is where this customer is coming from when the DNS gets the query, so that the answer can be tailored to that. Or we've got little routing hints that are going to tell you, no, I want to make sure that this stays in this region or something like that. That's the kind of thing that I anticipate we're going to start to see. And there is a downside to this, particularly on the privacy end, and that is that you can correlate these users across these different activities, and naturally, there's some data leakage about that. And this is not very end-to-endy, right? It's the kind of thing that says, well, the network's doing fancy stuff in the middle. We, in the DNS world, I call this stupid DNS tricks. There's all kinds of things that you can do that are kind of mucky. And they look like nasty stuff that's happening inside the network that should be, really pushed to the edge, and it can't be. But the good news about this is that the technologies that are really invasive, the kind of thing that really gets in the way, the sorts of things where packets are munged up and made a muck of, those things don't work very well, and they cause support costs. And this is one of the main things that is the good news out of this kind of infrastructure providers that are dividing up the world in the middle. What happens is we can't afford to get a call. One call can wipe out your entire profit from that customer, or at the bottom end, for the entire year you can lose your profit. If you get a single call, you got to have them on the phone. So we can't have these kind of corner cases, and that means that it tends to be a very predictable network that we want to have. And the more stuff that's in the way, the worse it is. And that's a very end-to-endy kind of network. I do have, though, some things that I hope will therefore emerge from this. And one of them, and this is probably just wishful thinking rather than a prediction, one of them is that we'll develop protocols that give enough hints so that you can do these tricks without them being really harmful. So we need stuff that allows you to make intelligent decisions in the middle, allow the infrastructure to give different kinds of tailored responses or whatever, in an effort to make that experience as good as possible, to keep the latency as low as possible. My customers measure us all the time, and believe me, if we get an extra 10 milliseconds of latency anywhere in the network, I know about it within minutes. The other problem, of course, is that if we get these kind of cracks in network neutrality and they become a complete breach, then we've got a really big problem. Because the kinds of networks that we're talking about in those cases are, really sort of the one owner owns it all and tries to keep everything within it. And at that point, we've got a network that these kinds of hints actually just won't work in. And so that's one of the things that I think is the biggest threat to these kinds of predictions. When I say, well, I think that we're going to get these kinds of specialized infrastructure behavior in the middle of the network, and they're going to be doing these things on the basis of the hints. Well, none of that's going to be possible if network neutrality doesn't continue to work. And with that, that's all I had to say. Thank you.
Okay, thanks. Don't run away just yet. A couple of questions for you, and this time I'll warn Harold and Fred that I'll ask them if they have any questions. But before I get to that, so you have a very particular view of infrastructure and what a modern application looks like today that maybe not everybody in the room entirely shares. Could you say a few words about what you think an application looks like today and why infrastructure is so important?
Yeah, so one of the things that has happened over time, we think of applications or the traditional sort of view. Somebody said yesterday that this is a very wire to the ends kind of view. You've got, one client and it's talking to something in a server, and there's a clear endpoint, and there's a sort of network in between. And the actual network applications that people are building anymore don't look like that, right? The application isn't in a place. It's spread around the network. There are various parts, and it doesn't really matter. Where the service comes from or anything like that. And it's all stitched together in these little pieces. And in fact, the little pieces are talking to one another, and they're not necessarily coming from the same machine. And so the application, from the user's point of view, the thing that the user sees is actually a whole bunch of little things all stitched together. Now, of course, that shouldn't be news to anybody here, but that makes for an application environment that is very different. And so the infrastructure on which this is running is built with the idea that any one of those pieces could just disappear and it's not a big deal. I have customers, for instance, that send data to us, and I want them to send me like this nice stream of data and then make changes in orderly chunks. But they can't do that because they're running in AWS, and their region stuff could just go away at any moment. And so they send things to me blindly and never expect a confirmation. And I've got to be prepared, to send that all the time. And that's just a normal sort of application environment. Once you've got that kind of environment, you don't have a situation where you can say, oh, well, this application out here is smart, and so it can do all of the things. The network actually needs to be able to stitch those things together, or else you just don't have an application at all.
Thanks. Harold, Fred, comments, questions?
No, really.
Okay. All right. Warnings don't help. Harold, go ahead.
So
let me see. This is a Mac, so there should be a way to get to the next slide. Yep. So I was asked to do endpoint from an endpoint perspective. Well, one of the problems with doing that is that the endpoint is an undefined term. Or rather, it's a well-defined term that varies completely with what you're looking at. Usually, platforms at the endpoint at the moment are beholden to many masters. The telephone is, this mobile phone thing is typical. This thing actually has a commitment to my telephone provider to only ring when its number is called. It's got a commitment to Facebook to tell Facebook where I am. It's got a commitment to me to actually start when I press the button. It sometimes fails at that too. But this is kind of, it's a complex picture. And of course, there's other pieces that could be called endpoints, like the customer, the one who pays for it all, or the user who actually tries to make it be useful. But I could talk about that forever, but I was told that I should talk for 5 minutes. So I'll just pick one. Let's talk about applications. Application, think about Facebook, Runkeeper, Angry Birds, whatever. Typical thing of an application is that it has a direct relationship with the user. And it has a reason to exist. And it relates somehow to something running on endpoints that we call endpoints, and something running on backend resources that also are called endpoints, but can include many forms of services. The one thing it doesn't have a direct relationship with is, in fact, the network. One should always include a joke. So one of the jokes that I remember from before the fall of before the end of the Cold War, a journalist walked up to a Pole and asked, "Do you consider the Russians to be your friends or your brothers?" "Of course, they're my brothers. Friends are the ones you pick for yourself." The network is not my friend. The network, as I wander around, changing from attachment point to attachment point, as the many instances of me as an application connect to a million different access points, million different ways to connect. This is stuff that is controlled by not me. None of it, the operators of this, have my well-being at heart. And none of these have any particular interest in a specific case in me doing well. And none of them are under my control. But I depend on it. I depend on the network infrastructure to gain customer. I depend on the network to reach my customer. I can't hide from the network. And if the network goes away, I have no purpose in life. I am an application. I hope that's not so true for humans, but sometimes I wonder. So there's a dialectic tension here that will not go away. I have to trust the network in order to get anything done, and I don't want to. So, being an application end to end means from me to me. It means from my instance on the user's endpoint to my instance on the backend endpoint between the stuff I control and the stuff I control. Because these two ends trust each other. There are various ends that trust each other for various reasons. I might trust some of Andrew's servers because I have an agreement with him to provide service to me. But on all the stuff that is in the middle, all the stuff that makes up the internet, I have to extend trust and to some degree do it blindly. And I will extend the absolute minimum of trust I can get away with. I will take the resources I can get, and if I don't get the behavior I'm expecting, I will do what it takes to make things work. If I could wish for what the network would do for me being an application, I would wish for consistency. That at least if things go haywire, let them go wrong in only one way. Won't happen. One of the things that 3G does for you is if you walk behind a tree, 3G will happily buffer up your packets and send them to you, send them on when you come out from behind the tree. Whatever you were doing behind that tree, it might have taken a long time. So instead of packet loss, we get delay. Well, I'll work around that. But I prefer that I can only have to adapt once. So in many cases, I go, hey, network, please stop helping me. Deliver something consistent, something that is simple for me to understand and relate to. Stop helping me. I was asked about predicting the future. This is kind of predicting the present, which is much harder because it can be verified. So I'm hoping to see Fred's network that actually becomes not dumb, but offering services in a simple model over which I can reach Andrew's infrastructure so that I can get the services I need to build my components, seen from an application perspective, that I can extend trust to the minimum amount possible and deliver a service to the user because that is my purpose. Let the network be simple.
Okay, before you sit down, a question or two. A wonderful characterization in helping us think about what applications, what endpoints are today. I wonder if you could be a little concrete in terms of how you view, say, this device, a phone. Is that an endpoint or how is it not an endpoint?
It depends on perspective again. The nice thing about this that characterizes it as an endpoint is if I throw it away, it goes away. Well, if I remember to turn it off at least. It's under some degree of single control. Therefore, it is an endpoint. But within this, there are many layers of complexity that say the endpoint that is my Facebook app is the endpoint for my communication with Facebook. The endpoint that is my SIM card is the endpoint for communication with my telco provider. So it gets very complicated.
How about the endpoint, which is your hotspot?
Well, the question is, do I relate to it? I mean, my hotspot talks various things to various places, including routing protocols. So for the routing protocol, it is an endpoint. For Facebook, it ought to be totally invisible. So it's not an endpoint for my Facebook app. So it all depends on perspective, which is horrible for saying, oh, I have a clear definition, but rather useful for applying the principle.
Any other questions, Andrew?
Not yet. I'm slow.
Okay, all right, Harold, thank you. And I'm going to leave this mic on the table so you don't all have to fight over one. All right, so let's see if we can focus on some sort of general discussion. I think there are it strikes me, two ways in which we get increasing challenges to our perceptions of the end-to-end model, of the end-to-end reality at any point in time. One of which is challenges for things that are not helpful and introducing complexity in the network, like network address translators have been reviled for decades. And things that are, as you said, Harold, trying to be helpful, when everybody tries to be helpful, but everybody tries to be helpful at different layers at the same time. And in fact, the Salzer paper gives an example of the latter case when there was a router that implemented error correcting within the actual router. And so all the application developers said, fine, I don't need to waste my cycles doing error checking on the files that I transmit over FTP because there's error checking in the router, no problem. Of course, the problem was that it was faulty on the router, and so they actually crashed a whole bunch of files before they figured out where the problem was. The point being, if everybody is trying to help, you may actually wind up not getting the help at the level at which you need it, or you may set expectations that are not necessarily appropriate. So comments from the panel in terms of where do we see major challenges to the end-to-end model, either in terms of those not helpful evolutions of things that introduce unnecessary complexity, or in terms of what happens when everybody helps?
Yeah, so this mic may actually be, there we are. So this was the thing that I said not yet about when Harold was talking, because it's true that you want maybe people to stop helping, but the problem is that in the environment that I was talking about, where you've got all these different people who are providing bits and pieces of the infrastructure in a coordinated way, they're only loosely coordinated, right? Because it's many different vendors, and there's no support in most of the protocols to coordinate that kind of activity. So instead, what happens is everybody has to figure out for themselves, oh, how can I help this along? And you can have things. So two things that can happen there is that either you can have things that are sort of horribly broken, and they're in the network, and then everybody has to live with it, or else we abuse different layers in order to try to make this stuff work. And the obvious example of this is the way that people use tricky things in the DNS in an effort to try to make things show up in the right way. And I picked that example mostly because I know it well, but it's certainly not unique. And so what will happen is, for instance, people have a thing in a single data center, but they've got data centers all over the place. So then they're trying to sort of figure out how do they nail people to a particular data center, and then give out answers just so. And naturally, then there are caches in the network that have remembered things, and stuff goes to the wrong place. We're to the point now where we see people turning their TTLs down to 30 seconds or less in an effort to try to keep enough fresh stuff in the DNS. And of course, this system scaled pretty well, partly because of the effectiveness of caches. And if we throw all of that away in a desperate effort to make sure that all of the traffic goes to the right data center, we're giving up a great deal. And I think that that's actually true at every layer that you can think of, right? That you end up with every system, from layer 7 pretty much on down, you can do nasty tricks with it in an effort to try to get exactly the behavior you want. And I think that that's really what Harold is complaining about. And it seems to me that if we want not to do that, then instead what we've got to do is figure out how do we make the network exactly cooperative with the goal that we had.
So one of the things that has bothered me all these years I've been working with the internet is my vocabulary for telling the network what I want is very, 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 very limited. I can hand it a packet and say, here's where it should, the direction in which it should go. And I can hand them it 2 packets and say, they should both go in this direction. But until relatively recently, I couldn't even tell it, but if you have to choose between the packets and only send one of them, send this one. There are interfaces that are appearing that allow me to say, okay, I'll put an important mark on this packet and not put it on the other packet. And sometimes the network will behave appropriately. But unless I can tell the network what I want, it's not a surprise that it won't deliver it.
Well, and of course, we've worked fairly hard to give applications the ability to put those marks in. That's where the diffs code point is, for example. And what we find quite often is that the network turns it off because it doesn't want to deliver that service. What we really need is the evil bit. You know, could all the bad stuff please set it?
We wouldn't be able to set the user space.
Yeah.
Okay, so in a few moments I will open up the mic lines to the floor if people have questions in mind and want to start lining up. But I do want to make sure that we think about the larger question here, the question of whether or not the end-to-end principle matters in today's internet and going forward, and if so, how. And again, I want to sort of come back to the basic principles of if we want to have a robust, resilient internet going forward, is this at least a way of thinking about how to get the right kind of building blocks between the network and the applications and the infrastructure going forward, or is it just, it was a nice paper 2 decades ago and let's be moving on then? So comments from the panel.
Well, I think the end-to-end principle, at least as I enunciated it, is terribly important. Basically because the network operators can't deliver a service that they can sell if that's not true.
And the end-to-end principle is a principle which usually means that it's honor in a breach. But holding back the floodgates of Byzantine complexity that would result from abandoning it is a worthwhile effort. We need it, and we need to make it happen in practice, because it's one of the guidelines, the Occam's razors of protocol and service design. If you can't tell that it's end-to-end, if you can't enunciate for a specific function what the ends are, your design is wrong.
So I guess I sort of suggested this in what I had to say earlier, but fundamentally, if you have a network that is a whole lot smarter than the end-to-end, pretty much as Fred enunciated it, then you can't build these sorts of tricky services on top of it. And I think that in particular, the cost advantages of that are just so great that there's tremendous economic pressure in that direction. And for that reason, I mean, it's pure pragmatics, which is not normally where I live, but it's a purely pragmatic question that I think the pressure is there, the economic pressure is fortunately there to keep this as one of the core principles of how we build this network. I think that people who build big integrated things on top of the internet today are fools, because they're building for themselves a system that they can't touch, and it can't grow, and it can't change. And you know, I'm loath to predict what would happen in 6 years, because my crystal ball is just not that good.
Okay, thank you. All right, so we'll go to the mic lines now, and again, I would ask if you would identify yourself when you speak into the mic. Go ahead.
My name is Tim Gray. One of the important characteristics, it seems to me, of the end-to-end principle is that it's really my end, the other end, and nobody else in between. And obviously, the elephant in the room is the worry that maybe somebody else isn't on that connection that shouldn't be. And I'm starting to become convinced that for a connection to be effectively, usably end-to-end, it should probably be encrypted by default at all times, everything. And I'd love to hear what kind of things about that.
Speaking from the end, that's a matter of trust. I noted in my talk that in many cases you want to extend as little trust as possible. One of the ways in which we extend trust is that we trust the network to not share information with others. If we don't want to extend that trust, we encrypt. If we don't care if the network shares that information or not, we don't. I see encryption, which is becoming cheaper all the time, as becoming more natural as time goes by.
So I would agree with that. To the extent that we can encrypt everything, that's a good thing. I do have a question, and that is when we talk about the elephant in the room is not content capture; it's data retention. So who called who, what was the URL that they accessed, and all that kind of thing. And I'm sorry, the places where that's measured, either the data has already been decrypted or the header in question is visible in flight. So not sure that encryption actually addresses the question that is triggering this, but it's certainly a good thing.
I think we have a whole herd of elephants in the room.
So what with all these elephants, I'm going to sneak in. I really want to make a distinction between the data and the metadata about about a given packet, because and I think this is something that Fred is mentioning as well. There's no way that you can build some of the things that we want to build and have complete privacy end to end in the purest sense of the word, and this is just a fact of what happens when you do things in public. And I'm worried that some of the things that people are proposing amount to a picture of the world in which there's exactly one server at the other end and exactly one client, and you're talking back and forth between these two things, and there's perfect security between them. And I think that is a picture of what one of those ends looks like that is not an accurate picture of the way the world is. And as long as we appreciate that one of those ends is actually sort of, a proxy for a whole bunch of things behind it that are actually talking to one another, then okay, maybe we're all right. But then, as Fred says, at that point you're already decrypted, and then you've got these things talking to one another or something. There's going to be some information leakage there. And I don't know how to get around that thing unless we have some mechanism in what we're building which attends to this difference and says, no, this part really is the one that's secret, and this stuff is, yes, it's susceptible to analysis in the bulk, but it's not susceptible to analysis in the individual cases. How to design those for each case, I'm not exactly sure, but that's the kind of thing that I have in mind as a general principle.
Is the mic on?
I'm not actually sure that it is.
Perhaps speak louder.
Okay, Bob Briscoe, BT. I want to talk about architectural reinforcement, which cryptography is part of, but as you've started going towards, it's more wider than that. Before I do, I just want to try and make it clear who we're reinforcing against, because unless you know that, you can't do it correctly. And it's not as simple as saying it's sort of network versus ends. because actually, being within an operator, I've seen over the years what the process is going on within an operator, and it's many different vendors having different ideas that will cause or allow some short-term gain for themselves and for the operator. So they will keep trying until they find someone who agrees with what they want to do. And usually that will be a product line inside one of the operators, which the architects inside that operator have to, they're enthralled to. And so there's this sort of tension between long-term evolvability and short-term gain. Now, we also need to recognize that you only need long-term evolvability in order to make a return on that investment. So we shouldn't forget that you do need to make a return on the investment, and that is the short-term gain. It's not all about evolvability. We do need a period when you actually use the thing. Right? And so we need this tension to exist to find out the new things people want. And so we want to be very careful about reinforcing the architecture, that we don't go too far and block the things that are showing us that the architecture is actually wrong for current needs. Right?
I don't want to interrupt you, but we do only have about 5 minutes left in the session. So.
Yeah. Okay. So the point I wanted to get to is that one of the areas you were getting towards is not just encryption of payloads, but also protection of the headers and addressing information and things. And the other area where I think we could usefully go and have some action out of this is to recommend a process for dealing with that, in that RFCs should have, just like they have a security consideration section, they should have a backward and forward compatibility section. Right? And forward compatibility means make sure that your reserve fields are properly defined and maybe randomized, or there's something in there to stop them being zeroed or packets dropped when things are put in there and all that sort of stuff. It's tricky work, it's subtle, and that's why we need to actually bring it out in every time we have a standards track document.
So that sounds like it would be an excellent contribution to make to the security directorate meeting if you have the opportunity this week. Elliot?
Hi, good afternoon. Elliot Lear here. I'm reminded that the end-to-end model doesn't necessarily mean that we're talking about a two-party communication. And I'm also mindful that when the papers were written, mostly it was assumed that at least the two ends were going to function correctly in a cooperative manner. And that there's a lot of ends out there today that really want to hurt the other end. And so to answer your question, Leslie, in my own mind, I believe the end-to-end model is absolutely required. The question is, do we have the right cooperative model at the application layers to address the threats that the ends now face today? And that's my question to the panel. Thank you.
Panel?
Well, no, because the bad stuff does not set the evil bit.
To some degree, I agree. I mean, the bad guys are always out to get you. And the bad guys are on the internet. And the bad guys are running my application and doing stuff to it that I did not want them to do. But that's part of why we need to think clearly about extending trust and extending the trust that is needed and having clear thinking about what happens if.
I might have sent a minute earlier. But Fred, also, I heard you, I think, correctly summarize the end-to-end paper in saying, well, we should only put special behaviors in the network, if there's really a good reason. But when we meet with AT&T and Verizon and these 3G companies, we say, why would you deliver my packet a minute late? And they say, well, we had a really good reason to do it that way, which is that when we designed it that way, most of the traffic benefited. And that might not be true today. Maybe most of the traffic doesn't benefit, but it did when we designed it that way. So what sort of mechanisms do you think that the IETF or other standardizers could build so that we don't start relying on the behavior of most traffic now to build in mechanisms in the network that might not be true in 10 years?
Well, unfortunately, omniscience is kind of reserved for people other than us. It would be really nice if I could predict all of the needs that we'll have 10 years from now. What I have found in my career is that the best thing I can do is maintain simplicity and the ability to change things so that as new requirements come around, then we can go do something with them. If I can make things be, in mathematical terms, elegant, then that gives me the right answer. Coming back to 3G and what happens when I step behind the tree, I'm actually quite all right with a packet being held up for a few milliseconds, perhaps as long as a TCP RTO. At the point where it's being held for minutes, that's not a benefit. And what I really expect then is for the service underneath to say, I think there's going to be a retransmission of that packet coming, or maybe the session's dropping, or something else is happening. The time has come to set this one aside. And I would hope that the service is smart enough to do that.
I'm getting kind of worried about what's going on behind that tree, but I think we better also move along to get Leisha's question in as the last question. Leisha?
And
who are you?
Leisha Zhang. I think, I came in late, but sounds like people do agree with the principle that is the end-to-end principle should extend, to the next 10 years, to the next 10 years. It seems that there's a question or challenge of the execution. That is, with all these complexities in the middle and the controls in the middle, how do you implement? For that, I'd like to just offer a comment. BitTorrent is one specific application. Is this end-to-end or is this not end-to-end? I think in terms of the data that one wants to get, it is end-to-end. A few years back, a few of my friends, my students, just for the fun of it, tried to play with BitTorrent, injected the wrong data into it, and very quickly, their nodes wouldn't be able to do anything because BitTorrent had this verification on the data chunks. Injecting any bad chunks get you out of the network. So therefore, I think the end-to-end principle could be implemented as like a connection from one end to the other end. It could also be implemented in different ways. That is to secure the data that you want to get from the producer. That can be implemented not necessarily by direct connections, but could be implemented by the peer-to-peer networking and still allow the data consumers verify the provenance of the data.
I think a model that's actually a little more accessible than BitTorrent is the mail model, SMTP. You actually have two variations on end-to-end there, and that is between two MTAs, or an MUA and its MTA, and between the two endpoints, the person who sent the mail going to the person who ultimately receives it. And I think the end-to-end principle applies in both cases, but in different ways. I would agree with you that data needs to be encrypted at rest, because quite often the place that we get into things, at least what I've read about what NSA is doing, they don't tell me, of course, but they quite often get into a database or someplace where the data is in fact at rest, or they're looking at an MTA and looking at data that is temporarily at rest while in transit. And so I think those are, in fact, very important places as we look at the pervasive monitoring issues. But the end-to-end principle, we have to look both at originator to to the person it's delivered to and the individual hops along the way.
So I think we're not done by any stretch of the imagination, but unfortunately we've run out of time. So I would like to thank our panelists very much for their efforts. And if you would kindly take your lunch remains with you on your way out the door, it would be greatly appreciated by the next users of this room.